Do you feel like this year's heat is abnormally intense? Well, it's not just you. According to a new report, there is an 80% chance we'll break high temperature records again in the next 5 years. Yes, that means it could get even hotter. Airport runways have cracked from the heat, and even the Eiffel Tower has warped. The Arctic is warming 3.5 times faster than the global average. But just as you might start fearing Earth is turning into Venus 2.0, here's a scientific fact that completely flips the script. We are actually living in a long ice age. Specifically, we're in a relatively warm phase called an interglacial. So, when is the next big freeze coming? To find out, we need to travel back millions of years, feel Earth's climatic pulse, and search for clues. We're going to witness a grand, decisive era that shaped the future of life on Earth. This was the last ice age. This journey will show you just how extreme the environments on our planet can be. Over 100,000 years ago, massive ice sheets, biting polar winds, and barren landscapes reshaped our planet's ecosystems. This was a harsh glacial period, with extreme cold lasting for thousands of years. As it ended, many iconic species mysteriously vanished, for reasons that still puzzle us today. What you're experiencing isn't Earth's first ice age. In fact, our planet has gone through 5 of them. So, what do they all have in common? An ice age is a long-term period of extreme cold, lasting millions of years, where huge parts of the Earth are covered by ice. The one we usually talk about, the last ice age, began about 2.6 million years ago. And here's the shocker, we are still in it. You see, every ice age has 2 phases, cold glacial periods and warm interglacials. We are currently in the latest interglacial, which has lasted for about 11,000 years. So when people mention the last ice age, they're usually talking about the last glacial maximum, the big freeze that happened right before our current warm spell, from about 115,000 to 11,700 years ago. Here's another surprise. During that deep freeze, global average temperatures were only about 6 degrees Celsius lower than today, but even a single-digit difference has a massive impact. A 6-degree global drop means a huge loss of heat from the oceans, land, and atmosphere. During the last glacial maximum, much of Europe and North America was buried under 2 gigantic ice sheets. All that water being locked up in ice meant sea levels were much lower. The land was mostly cold grasslands. No single factor explains why Earth gets so cold, but studying its orbit gives us a lot of answers. A Serbian scientist named Milutin Milankovic proposed that long-term changes in Earth's position are a powerful driver of climate. He studied 3 cosmic motions that change how much solar radiation we get, known as the Milankovitch cycles. First, there's orbital eccentricity. Earth's orbit around the Sun isn't a perfect circle. It can get more elliptical, or oval-shaped, thanks to the pull of Jupiter and Saturn. This cycle lasts about 100,000 years. A more elliptical orbit means we get farther from the Sun at certain times of the year, leading to cooler, longer summers that don't melt the winter snow. Second is axial tilt. Earth's axis isn't straight up and down, it's tilted. The angle of this tilt changes over a 41,000-year cycle. A smaller tilt means less extreme seasons. Milder summers can't melt the previous winter's ice, allowing glaciers to grow and potentially trigger an ice age. And third, we have axial precession. This is the wobble of Earth's axis, like a spinning top, caused by the gravitational pull of the Sun and Moon. This 26,000-year cycle alters seasonal contrasts, making them more or less extreme. The combination of these 3 cycles is a pretty reliable predictor of major ice ages. So, the big question is, how did the creatures roaming our planet adapt to all this? What did they look like? The last glacial maximum was the era of megafauna, and mega is no exaggerations. Some of these creatures weighed up to 4,500 kilograms. Why was everything so big back then? One idea is Bergmann's rule, which says that in colder climates, mammals grow larger because a bigger body loses heat more slowly. This might be why the Pleistocene gave us so many massive, awe-inspiring species. Let's start with the most famous one, the woolly mammoth. For many of us, the woolly mammoth is the symbol of the Ice Age, but they weren't actually much larger than modern elephants. They did have some key differences though. Woolly mammoths had a double-layered coat for warmth, shorter legs, a 9-centimeter thick layer of fat, and small fur-covered ears to prevent heat loss. They eventually went extinct, but not all at once. A small population actually survived on an island in the Arctic until about 4,000 years ago. That's 1,000 years after the Great Pyramid of Giza was built. Next, meet a weirder creature, the glyptodont. Its name means carved tooth, perfect for grinding tough plants. These were huge two-ton animals that looked like a cross between a giant armadillo and a tank. Their bodies were protected by a massive shell, but unlike armadillos, they couldn't roll into a ball. You might think they were slow, but recent studies suggest they could actually stand on their hind legs, using their spiked tails to attack or reach for food. Then there were the giant ground sloths. Today's sloths are tiny, but back then, some were the size of elephants. One species, Megatherium, had the height of a giraffe and the bulk of an elephant. Some of these giant sloths even dug enormous burrows to stay warm or hide from predators. And what kind of predator would dare to take them on? Probably something like a saber-toothed cat or a giant short-faced bear. When you see these massive, resilient creatures braving extreme weather and giant predators, you'd expect them to survive, but that's not what happened. At the end of the Pleistocene, they vanished. In Australia and the Americas, up to 88% of large species went extinct. How some blame natural climate change. As the world warmed up, rising sea levels cut off migration routes. But that doesn't explain why the mammoths on Wrangel Island survived so much longer. Another major theory points to a new player on the scene: humans. Our own species, Homo sapiens, evolved around 300,000 years ago and spread across the globe, sharing the land with all this megafauna. Could we be responsible for their extinction? Around 50,000 years ago, human culture took a huge leap forward. Toolmaking improved dramatically, which made hunting much more effective. A lone human trying to take on a woolly mammoth wouldn't stand a chance, but a group armed with sharp spears that could be thrown 40 meters, that's a different story. One famous hunting group was the Clovis people in North America. Within a few thousand years of their arrival, the megafauna disappeared. A recent study of a Clovis child's remains found that woolly mammoths made up a huge part of their mother's diet, suggesting that intensive hunting could have driven these animals to extinction. The pattern is similar in Australia, where 85% of large species disappeared shortly after humans arrived. And it wasn't just animals. Our close relatives, the Neanderthals, also vanished around 40,000 years ago. They were the first humans to survive in glacial ecosystems, with stocky builds and large noses to warm the cold air. They had complex cultures, so how did they meet their end? You guessed it, we might be responsible. We may have outcompeted them or simply absorbed them into our larger populations. In fact, most people of Eurasian descent share 1% to 2% of their DNA with Neanderthals. The last ice age brought massive changes that forever altered Earth's history. As we pull our thoughts back to the present, you can't help but be struck by the era's incredible biodiversity. Though most of those creatures are gone, their fossils still spark our curiosity. But perhaps the more troubling question is, could this happen again? We are still in an ice age after all. Is the next glacial period on its way? Remember those abrupt cooling events called Heinrich events? They happen when huge chunks of ice break off into the ocean. And data shows that before these events, ocean warming tends to destabilize the ice sheets. We're seeing those very signs right now. They could be a warning. Thanks for watching. If you found this journey through the Ice Age fascinating, don't forget to like, share, and subscribe for more deep dives into our planet's incredible past.